Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is binary tree to BST, and it is an easy level problem. So the problem statement says that we have been given a binary tree and we have to convert it into a binary search tree in such a way that the original structure of the binary tree is intact, right? So what do we mean by the structure? So for example, we have one node here and one node to the left and one node to the right. This structure should be as it is. It's such that the values can change its places. Now, if we have a look at the time and space complexity, the time is n log n and the space is O of n. And we also have this particular information that the driver code is going to print the in-order traversal of the converted BST to verify whether it is a correct binary search tree or not. So this is also just verifying of some facts. So let me just explain you what happens whenever we have a binary search tree, right? Its in-order traversal is always sorted, right? So this is like you can say this is a fact, or this is an important property of a binary search tree, that its in-order traversal is always sorted. And let us see how. So for example, we have three nodes. This node is, let's say, B, this node is, let's say, A, this node is, let's say, C, right? Now we already know that A is going to be less than B and B is going to be less than C, because on the left side of B all the elements that are smaller than B should be present, and on the right side of B all the elements that are bigger than B should be present, right? If we talk about in-order traversal, for in-order traversal we perform the left traversal first, and then we come to the root node, and then we perform the right traversal first. So you see all the elements are being accessed in the correct order of their values. So A was the smallest, that is why A was accessed first, then B, and then C. So we know that this is a property of a BST, that the in-order traversal is always sorted. Now we want to modify the given binary tree in such a way such that its in-order traversal is sorted. Now we had a look at this particular time complexity n log n, and the space complexity is O of n. By judging this particular complexity, we can try to solve it problem very easily with the help of a vector or an array, right? So what are we actually going to do? We can store all the elements present in the original tree inside a vector, and that will take O of n space. We can sort that particular vector. This will take O of n log n time, and then we already know what is the correct order that we should insert the elements in the tree, and in that order we are just going to replace the values in the original tree. So for example, if I have this particular tree like this, right, and let's say it has some random values for now. It is 10, it is 20, it is 1, it is 12, and it is 15. Right. So what I'll do, I'll traverse through the whole tree and I'll store all the values in an array or a vector. So let's say I have these values with me and I have already sorted them. Right. So the values will look something like this after sorting. So now I'm just going to make an in-order traversal through this particular tree. Right. And during my in-order traversal, I'm just going to put these values in the tree. So I'm going to replace the original values. And for example, if I perform an in-order traversal, first I'm going to go to the left, and then again I can go to the left, and since I cannot go to the left anymore, I'm going to come back to the root node, and then I'm going to put the value here. So 1 will be present here. Now I am just going to traverse back. Since I've already visited the left for this particular node, I'm going to put the value here 10, and then I'm going to move to the right. Right. Now I try to go to the left, but there is no left node, so I come back from here, and then I put the next value, it is 12 here. Right. So I traverse back to the root node, and that is this particular node. Since I have already traversed my left subtree, I'm going to put the value 15 here, and then I'm going to go to the right subtree, and then I try to go to the left from here, but there are no left node, so I come back to the root node, and then I put the value 20 here. Right. So you see, in this way we did not change the structure of the tree, but we did change the values, and now if you perform the in-order traversal of this particular tree, you're always going to get all the values in sorted order. Right. So this is exactly what you had to do. First of all, you'll have to store all the values, in array, in vector or array, right? Then you have to sort the vector that you got, and then put values in tree during in-order traversal, right? So this is exactly what you have to do in this particular problem. So this is the first step, this is the second step, and this is the third step. If you perform all of these three operations, your binary tree will not have its structure changed, and it will also be a binary search tree. Right. So let me just show you my final code, what I did. So you see, I have a vector of integers, that is values, and I'm going to call a DFS function. So it is just going to traverse through the tree. Now the order of traversal is not important here because we are just going to sort the values anyway. Right. So if my current pointer is null, I'm just going to return from here. Otherwise, I push the current value in my values vector, and I call my DFS function on the left and the right subtrees respectively. Right. After this has been done, I'm going to sort the values vector, and I'm sorting it in decreasing order. Right. We need to place the values in increasing order, but I'm sorting it in decreasing order. You'll see in a while why this is important. But after this has been completed, I call my build function. And inside my build function, if my current pointer is null, I'm just going to return from here. I'm going to call my build on the left half first, and then I'm going to process the data for the current node, and then I'm going to call the build function on the right node. Now, why did I sorted the vector in reverse order? So what I can do, if I have the array in reverse order, the smallest value will be at the back. So what I can do, I can just take the value from the back and just pop back the last value. Right. So this operation is only possible when you are popping values from the back. This particular operation, values dot pop back, is O of 1. But if you try to do the same thing from front, if you do values dot pop front, it is going to take O of n time. Right. So since this operation is O of 1, and now I don't have to maintain any extra pointer. If you had the vector sorted in increasing order and you are not able to pop the values from the vector, then at each step you will have to maintain a pointer which is going to denote the next element that you can insert. But since I'm just removing the values from the vector once they are used, I can use this particular method without maintaining any extra pointer and without using any extra time. Right. So this is why I sorted this particular vector in decreasing order. I just took the value from the back and I just popped it back from the vector. So that was it for today's problem of the day. Now let me quickly summarize this and show you that this particular code works. So you see, it passes all the test cases and this solution is absolutely correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video was actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So share the channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.